Hey guys, today we're going to talk about polar coordinates and how we can convert those to vector components. So here's a little bit of review of notation. So when we see parentheses, comma, a couple numbers there, that's just a coordinate point, an x and y coordinate. When we see the same numbers, but the parentheses are a little pointy now, those are vector components. So the terminal point would be at this coordinate point here, negative 40, 30, but now there's a vector that goes to that point. Okay, so let's go down to this first graph and graph that. So it says we're going to graph part B in standard position, meaning we're going to start at the origin, and we're going to let each increment equal 10 units. So the components were negative 40, 30, so the x component means go 40 left, 10, 20, 30, 40, and then the y component is 30, 10, 20, 30. So there's the point, negative 40, 30, but as a vector, that means I've got the initial side here at the origin, the terminal side at negative 40, 30, and the vector looks like that. Now when I go back to regular parentheses, but I've got negative 40 and then 30 degrees, that is a polar coordinate. Okay, and that is in the form r theta. Now when you graph polar coordinates, it's on a graph like this. It's circular, so that would be, that negative 40 would be the length of, or radius, of one of these circles, and it represents for the vector the magnitude. So we're in the form r theta, where r is the magnitude and theta, the number of degrees, is the direction. So we're going to graph C here on this graph. So it's negative 40, so 10, 20, 30, 40, and then 30 degrees, and when you have positive degrees, that means you're going counterclockwise, so 10, 20, 30 degrees. There's the vector from polar form. It's got a magnitude of 40, and negative 30 degrees is the direction. So that one was found by graphing negative 40, 30 degrees. We could also have used 40, which would have brought us out here, but then we would have to go all the way around to here. So to here is 180, 190, 200, and 210. So 40 and 210 degrees would give us the same vector. I could also have gone positive 40, so out to here, and then this way. It's clockwise, so that would be negative degrees, and that's going to be 150, so negative 150 degrees. So all three of these get us to that same vector. So now we're going to talk about how to relate polar coordinates and vector components. Okay, so convert from polar form to vector component form. So if I graph this, I'm not going to draw the circular graph, but if I graph it on a coordinate plane, a magnitude of 7 that goes out 7 and then rotates 32 degrees counterclockwise because it's positive. So it looks about like that. Component form, I need to find the x and y components. So I'm going to turn that into a right triangle. Here's the vector's x component, and here is the vector's y component. And I can use trigonometry to find those components. So there's my right angle. If I'm looking for the x component, I've got the adjacent leg, and 7 is the hypotenuse, so I'm going to use cosine. Cosine 32 degrees equals the adjacent, which is the vector's x component, over the hypotenuse 7. Okay, so I can cross multiply, so I get the vector's x component is 7 times cosine 32. And when I type that in my calculator, I don't need to write that. I'm trying to write that in component form. The vector's x component is 5.94. For the y component, I've got opposite and hypotenuse, so I'm going to use sine. So sine 32 equals the vector's y component over the hypotenuse. So the vector's y component is 7 sine 32. Okay, and when I multiply 7 by sine 32, I get 3.71. So here we are in component form. Now we're going to shorten that up by using some things that we already know and combining them with what we just did here. We've known for a while that x is related to cosine and y is related to sine. So when we're finding the x component, we're going to use cosine. When we're finding the y component, we are going to use sine. So the vector's x component will always be r cosine theta. And the vector's y component will always be r sine theta. So here, the vector's x component is 5 cosine 143. And the y component is 5 sine 143. Okay, so when you type that in your calculator, you're going to get the x component is negative 3.99. The y component is 3.01. I'd like you to pause the video and try C and D. Put those, or convert those from polar form to vector component form. So what you should have done is the vector's x component is 9 cosine 192. And the vector's y component is 9 sine 192. So you get an x component of negative 8.80 and a y component of negative 1.87. And for D, the x component is 14 cosine negative 23. And the y component is 14 sine negative 23. So that gives you an x component of 12.89 and a y component of negative 5.47. So that's how you convert between polar and coordinate, or component form, between polar and component form. And last, we are going to convert from polar coordinates to magnitude and direction form, which means in the end we want to just write magnitude equals direction equals. So a lot of times when I allow you to try this on your own, what ends up happening is you do all the work we did above to put it in component form, and then you use distance formula to get the magnitude, you use trigonometry to get the direction. But if we can just go back a page here quickly. Polar coordinate form is in the form r theta, which is magnitude and direction. So here's r, here's theta. The magnitude is 9, the direction is 192 degrees. The magnitude here is 14, the direction is negative 23 degrees. I'm going to add something here. I'm going to add a C. Okay, so very similar to B, except now with a negative here on R. The magnitude is always listed as a positive number. So the magnitude is 14. When you have a negative R and you write your magnitude as a positive number, that's the time when you've got to be careful about your direction. Okay, so negative 14, we'll say that's about right there. And negative 23 degrees means clockwise 23 degrees. So that's about what the vector would look like. But if we write positive 14 for the magnitude, usually you're going to want to go this way to the right. But we've got to rotate that all the way around to here. And that's not 23 degrees, that's 157 degrees. 180 minus 23. So the direction is 157 degrees. So be careful when R is negative and you have to find your direction.
Now we'll end the lesson with a little review. So first we are going to find the resultant vector, that's vector R, by combining these four given vectors. Okay, so to do this, we string these together head to tail. So what I like to do is leave the longest one right where it is, because that's the most drawing, and just string the shorter ones to it. Okay, so I'll just work my way around. So this vector here goes left 2 and up 3. And I'm going to take that and slide it down to here, slide this tail down to here, and go left 2 and up 3. So that vector is now moved down here. And then I'll go around to this next vector and slide it over to here, and that vector goes right 6 and up 3. So from here we'll go right 6 and up 3. So that puts us right there. And then this last vector, we're going to slide down to here. It goes right 2. And that is our final point. So we'll start at the initial tail. We will end right there at that final point. So this right here is vector R. Next, we are going to take these two vectors in component form and do 3 times vector v minus 2 times vector q. So that's 3 times this vector. Now 3 times this vector is 6, negative 3, minus 2 times this vector, and 2 times vector q is negative 10, 6. And now we will subtract. So we've got 3 times vector v here, minus 2 times vector q. 6 minus negative 10 is 16. And negative 3 minus 6 is negative 9. And last, we have a vector u that goes from 5, 6 to negative 1, 3. And we want to write the component form, the magnitude, and the direction. So to write this in component form, we have to do head minus tail. So component form is head minus tail. Okay, so it begins at the tail. So from, that's the tail, and to is the head. Head minus tail is negative 1 minus 5, and then 3 minus 6. Negative 1 minus 5 is negative 6. And 3 minus 6 is negative 3. So there it is in component form. Next, find the magnitude. Now the magnitude, we use the distance formula. So that's the square root of, and then we've got x minus x and y minus y. But we've already done that. We've done x minus x and y minus y and got negative 6. And that's going to be squared. Plus y minus y, which is negative 3 squared. So normally inside the distance formula, we subtract and square, but we've already done the subtracting, so we're moving on to just the squaring. Okay, so that is the square root of 36 plus 9, which is the square root of 45. Okay, now 45 is the same as 9 times 5. And 9 is a square number. The square root of 9 is 3. So the magnitude is 3 times the square root of 5. And last is the direction. Now, component form says that if we start here at the origin, this vertex or this vector goes 6 to the left and then 3 down. Okay, now I've got opposite and adjacent. That's tangent, which means arctangent will help me find the direction. So the direction is arctan, and then opposite over adjacent, -3 over -6. Okay, so in my calculator, I'm going to first make sure that I am in the right mode. I want to be in degree mode. Okay, then I'll do arctangent, so second tangent, -3 over -6, or I can do 3 over 6, canceling out the negatives, and I get 26.57. Okay, so this right here is 26.57 degrees, but that by itself is not the direction. We have to add this 180 here, so plus 180, and that is going to give us 206.57 degrees. So the direction is 206.57 degrees.